The dawn of thinking machines. An introduction. Artificial intelligence. We often call it AI. What is it really? Think of machines that can learn, machines that can reason, machines that can make decisions like us but built from metal and code. Today, AI is all around us. It's in our phones, helping us find answers. It's in hospitals, aiding doctors. It even helps us explore the vastness of space. This idea of intelligent creations is not new. Humanity has long imagined beings of our own making, beings that could think, beings that could act with purpose. This dream stretches back through millennia. It connects us to our ancient ancestors. They too pondered such possibilities. They too tried to build wonders. Consider the stories, the myths, tales of animated statues, legends of mechanical servants. These were early expressions of a deep human desire, a desire to understand intelligence. Whispers from antiquity, the Antikythera mechanism. Imagine a shipwreck lost beneath the waves for 2,000 years. Off the coast of a Greek island, Antikythera. In 1901, divers found something astonishing, a lump of corroded bronze. It didn't look like much at first, but inside a universe of complexity. This was the Antikythera mechanism, a treasure from the ancient world. What was this strange device? It was a sophisticated mechanical calculator, an analog computer, if you will, crafted with intricate bronze gears, dozens of them, interlocking precisely. Its makers were masters of their art. They understood the movements of the heavens and they encoded that knowledge in metal, a testament to forgotten genius. The Antikythera mechanism had a grand purpose. It could predict astronomical events. It showed the positions of the sun and moon. It could even foretell eclipses years in advance. Think about that power, to know when the sky would darken or when planets would align. Celestial navigators, the astrolabe's ingenuity. Long before GPS guided our journeys, there was another tool, a beautiful instrument of brass or bronze. It was called the astrolabe. For centuries, it was the smartphone of its time, a handheld analog computer. It connected humanity to the cosmos, a window to the stars, and a guide across the earth. The astrolabe was incredibly versatile. It could tell time, day or night. It could measure the height of stars and mountains. It helped sailors navigate vast oceans. Scholars used it for astronomy. Surveyors used it to map the land. Its intricate markings and moving parts were a map of the sky itself, a marvel of mathematical design. Consider its operation. You make an observation, perhaps the altitude of a star. This is your input. You adjust the astrolabe's movable components, the rete, the rule. These parts represent the celestial sphere. They process your input. Section 4, Early Mechanical Minds, Precursors to Computation. The dream of automated machines is ancient. It wasn't just about calculation, it was about creating movement, creating action without direct human effort. Hero of Alexandria, a brilliant inventor. He lived in Egypt almost 2,000 years ago. He designed devices that seemed magical, steam-powered engines that opened temple doors, automatic fountains, vending machines for holy water. These were early forms of automation. These creations, though perhaps simple by today's standards, showed a profound understanding of mechanics. They used principles of physics and engineering to create self-operating systems. Imagine the wonder they inspired. Doors opening as if by an unseen hand. Water flowing on command. This was the beginning of robotics, in a way. Machines performing tasks once done by humans or animals. A spark of artificial agency. Later, in medieval times, clockwork mechanisms blossomed. Great astronomical clocks were built in cathedrals. They did more than just tell time. Section 5. Echoes of logic, ancient decision-making tools. Computation wasn't always about gears and levers. Sometimes it was about simple, elegant tools, tools that helped the human mind. Consider the abacus, used for millennia across many cultures. From ancient Babylon to Rome to China, rows of beads on rods. It seems basic, yet it's incredibly powerful. It allows for rapid calculation, addition, subtraction, multiplication, division. The abacus is a physical representation of a number system. It externalizes the process of calculation. It offloads mental work onto a device. The user follows a set of rules, specific movements of the beads. These rules are like simple algorithms. If you follow them correctly, you get the right answer. This structured approach to problem solving, this is fundamental to how computers operate. A defined procedure leading to a defined outcome. Beyond calculation, there was the development of logic. Ancient philosophers like Aristotle, they studied the rules of reasoning, how to construct valid arguments, how to identify fallacies. This formalization of thought, syllogisms, deductive and inductive reasoning, these were attempts to understand the structure of thinking itself. Section 6. The unbroken thread. From ancient gears to modern code, there is a clear line, an unbroken thread of human ingenuity. It connects the ancient inventors to today's AI pioneers. The Antikythera mechanism with its complex gears. It tried to model the cosmos, to predict its movements. Modern AI does something similar but on a grander scale, creating complex simulations of weather or galaxies or even the human brain. The desire to model reality remains. The astrolabe, a personal computer of its time, it took real-world data. It processed it using its physical structure. It gave useful answers. Our smartphones do this constantly, taking our voice, our touch, our location, processing it through sophisticated algorithms and providing information, navigation, communication. The fundamental principle of input, process, output endures. The tools just became exponentially more powerful. Consider the abacus, a tool for automating calculation, freeing the mind for other tasks. This need for efficient computation, it drove the development of mechanical calculators. Section 7, our cosmic inheritance, the future of AI. So we've journeyed through time, from ancient gears to modern algorithms. We've seen how the seeds of AI were sown long ago, in the minds of curious inventors, in the workshops of skilled artisans, this quest to understand and replicate intelligence. It's part of our human story. A cosmic inheritance passed down through generations. Today's AI is not a sudden arrival, it's the latest chapter in a very long book. This journey shows us something profound. Humanity has always sought to extend its reach, to understand the universe